Hello guys, let's prove that on a second quadrant tan is negative. And we're going to be doing the proof without using the relation that tan is equals to sine by cos, without any graph and without any geometry. So why can't we use tan equals to sine by cos? Well, that would make things a bit too easy, because in my previous video I had proved that sine is positive and cosine is negative on the second quadrant, and you'll just have the relation tan equals to positive by negative, and hence tan will be negative. So let's just do the proof in a similar method as I did in the previous video. Now for this proof I'm going to have one axiom, meaning that this statement what I'm going to write, it will always be true, and we're going to have to write that. So here is our axiom: all trigonometric functions, which means sine, cos, sec, cosec, tan and cot, are positive for all angles between 0 to 90 degrees. So basically all angles between 0 to 90 degrees, the trigonometric functions, all 6 of them, will be positive. Now next what I'm going to do is I'm going to define an angle alpha, which is on the second quadrant. Now let's see the boundaries of this alpha. Let's see what the lower limit and upper limit is. For that we'll have to know the graph of quadrant 2, and this is not part of the proof, I'm just explaining it to you guys. So as you can see, this is the first quadrant, this is the second quadrant. Now for the first quadrant, if you start from here, this point, the origin and the x-axis, you can see for the first quadrant the angles go from 0 to 90, and for the second quadrant they go from 90 to 180. So this lies between 90 to 180 degrees. Now I'm not going to use is greater than or equals to, is greater than equals to, because these are extreme values, and these will give the values that we know. Basically tan 90 infinity, tan 180 0. We want to avoid that. So what we want to find is tan alpha, right? We somehow want to prove that this is negative. So what I'm going to do is, right here I'm going to let alpha be 90 degrees plus some angle theta. Now we also want to find the boundaries for this theta as well. And as you can see from this alpha, since it lies between 90 and 180, that means what we can do from here is, well, I'm going to remove this for now. You can see that from here theta is just alpha minus 90 degrees. So from here just subtract 90 from both sides, and then you'll get 0 to 180 degrees. And this alpha minus 90 is our theta. So that implies that theta lies between 0 and 90 degrees, which follows our axiom like this. So we can use this angle theta to prove that this is negative. But for tan it is kind of tricky, because we cannot do exactly what we did last time for sine and cos. So we'll have our tan alpha, and instead of tan alpha we can write it as tan 90 plus theta. Now of course you cannot simply write tan 90 plus theta as minus cot theta, because we first need to prove that tangent is negative, and that would be a circular reasoning. But what we can apply is the compound angle formula, tan a plus b. So here tan a plus b, I'll quickly write, is just tan a plus tan b, 1 minus tan a into tan b. Now the problem arises from this 90 over here, because if you put this over here you'll get tan 90, which is infinity. There's our problem, we'll get infinity over here. And what's worse is on the bottom you'll have 1 minus infinity into something, which will be 1 minus infinity, which is minus infinity. So you'll basically have an infinity by infinity case, which is indeterminate. However, we know that tan alpha must have a finite value, or a converging value. So what can we do? Well, I said earlier we cannot use the relation that tan is equals to sine by cos, but we can use the relation that tan is equals to 1 by cot. So this is just equals to 1 by cot 90 plus theta. Oops, what is that? 9. And now we can use the formula for cot A plus B instead, because cot 90 will just give us 0 instead of infinity. So I'm going to write it over here. Cot A plus B will be cot B into cot A minus 1 by cot B plus cot A. So you can just use some tricks around tan A plus B. Just you have to switch the reciprocals, and then you put this front and you put the B instead of A front, just like that. Now as you can see, we have 1 by cot A plus B, right? And what we can do is, well, we can simply switch the numerator and denominator, because that's what we're doing. We're taking the reciprocal of what we have over here. So we'll have on the top cot B plus cot A by cot B cot A minus 1. So we'll have cot B, which is cot theta, plus cot 90 by cot theta into cot 90 minus 1. Now, as I said earlier, this cot 90 is just 0, and this will be 0 minus 1, which is minus 1, and on the top we'll have cot theta. So finally, as you can see, this is just minus cot theta. And how do you know that cot theta is positive? Because we need this to be positive, otherwise negative times negative will be positive. Well, look at our first axiom. All trigonometric functions are positive for all angles between 0 and 90. And theta, right over here, lies between 0 and 90. Thus we know cot theta is positive. And finally, due to this minus sign, you can prove that tan alpha is negative, meaning that tangent is negative on the second quadrant. There we go, that is our proof, with no geometry, no graph, and not using the relation sine by cos. This is the only relation you'll need, and that is it. If you guys learned something new, please like and subscribe. Thank you.